Here we go. I'm going to try to explain to you why on the derivative of inverse cosecant of x, this x in the denominator has absolute value on it. So first we're going to jump over and we're going to look at the graph of sine, since the graph of cosecant and therefore the graph of inverse cosecant are based on the graph of sine. So we all know what the graph of sine looks like. What I'm worried about is what the graph of the inverse sine looks like. Well, to graph the inverse of sine, you'll note, well, we have 0, 0 on the graph of sine, which will be 0, 0 on the graph of inverse sine. Pi halves 1 on sine becomes 1 pi halves on the graph of inverse sine. But, well, let me show you what the computer thinks the graph of inverse sine looks like. That might not be what you expect. So this green curve is only part of the graph of sine. Why is that? Well, can you imagine? So from 0 to pi halves, right here on sine, is this green curve. Okay, so where is the rest of our sine curve? Well, we can't have it. This sine curve would curve back towards pi 0, which means the inverse sine curve would have curved back to 0 pi. Well, you would have the graph of something that's not a function. So we restrict the domain of sine from negative pi halves to pi halves in order to make the inverse of sine a function. Okay, so before I go on to the derivative of inverse cosecant, let's talk about just regular cosecant. Well, cosecant is the reciprocal function for sine, which means at any x value like 0, like pi halves, like pi, we can take the reciprocal of the sine value to get the cosecant value. So sine of pi halves is 1. Cosecant of pi halves should also be 1. The reciprocal of 1 is 1. Sine of pi over 6, I can't quite get it right in there. Sine of pi over 6 is 1/2, which means cosecant of pi over 6 is the reciprocal of 1/2, 2. And there are a whole lot of other numbers in here. So you could think right here, cosecant of some number a little less than pi halves is going to be the reciprocal of sine of a number a little less than pi halves. Well, a number a little less than pi halves gives a sine value a little less than 1, which will have a reciprocal a little more than 1. Gets a little tricky here at 0. Sine of 0 is 0. What's the reciprocal of 0? Well, 0 doesn't really have a reciprocal, but remember, sine is a ratio of two sides. Sine of 0 is 0 over 1. The reciprocal of 0 over 1 is 1 over 0. So every time sine is equal to 0, cosecant has a vertical asymptote. So all this blue stuff, that is the graph of cosecant. So just like the graph of sine and inverse sine, let me turn inverse sine back on. We don't keep all of the graph of sine. That would make the graph of inverse sine not a function. We don't keep the entire graph of cosecant, because the inverse cosecant would not be a function. So here is inverse cosecant's graph. Let's see if we can figure out where this comes from. So let's see, this looks to be, what is that right in there? That's got to be 1. So pi halves 1 is a point on cosecant, which means 1 pi halves is a point on the graph of inverse cosecant. From pi halves 1, the cosecant graph gets closer and closer to x equals 0, a vertical asymptote. From 1 pi halves, the graph of inverse cosecant gets closer and closer to y equals 0, horizontal asymptote. Hopefully you got that. You may need to go back and re-watch. I'm going to turn off cosecant to explain what we really came here for. And that is this stuff back here, the derivative of inverse cosecant. I hope you can do the algebra to get -1 over x times the square root of x squared minus 1. But this absolute value has to be here. If I put any number into x squared minus 1, take the square root, I'm going to get a positive number out. If I put any number into x, well, I'm going to get that same sign. But with the absolute value, no matter what, this absolute value becomes positive, which means overall y prime, the derivative of inverse cosecant of x, would be negative. And that's what I have. I want a negative slope. So a negative 1 over some positive number gives me a negative slope. So what you can see on the graph of inverse cosecant is the slope, no matter where you draw a tangent line, would be negative. So anywhere in here, you'd have a negative slope. This absolute value on the x in the denominator of the derivative of inverse cosecant preserves that negative slope.